Start this video by taking a look at the unit circle. I know that I gave everybody some templates and some guided notes to take along with this video, but just to introduce where we're going, I want to revert back to the unit circle in all its glory. So specifically, I want to focus on the idea of sine theta. Okay, so let's pretend like we're going to graph this. All right, we're going to type it in our calculator, or we're going to graph it on a coordinate plane with x's and y's, or in this case, thetas and y's. All right, and I'll get to what that looks like shortly, but I just want you to start thinking about this. So we're going to make a little table of values. All right, we're going to consider, so y is a dependent variable. Y is going to be whatever the value of sine theta is. So when theta is 0, right, I'm going to be finding the sine of 0. So how do I do that with a unit circle? I'm going to go to 0. I'm going to look at the y-coordinate. It's 0. And the next one I want to check is 30. All right, I want to check that. 30 degrees, the y-coordinate 1/2. So sine of 30, 1/2. I'm going to skip a little bit. I'm going to go on to 90. And when I get there, the y-coordinate is 1. I'm going to go on down to 180. I know I skipped a few things there. And what do you know, the sine of 180 is 0. Going down to 270, the y-coordinate, so the sine of 270, -1. And by the time we get back to 360, we're at sine 360, which is the same as sine 0, which is 0. So what is happening here? You notice that it passes through, it starts at 0, goes up to a max of 1, goes back to 0, a minimum of -1, and then back to 0. Now, of course, that was at 360 degrees. And as we know, 360 degrees represents one complete rotation around the circle. So, what are we to do with this? Well, let's say I was to plot these points. Right? And just briefly, I'll do that on a blank page, if I can find one. Okay, so just briefly, I'm going to do that. Y equals sine theta. So here's what I meant when we're going to plot this on a coordinate plane. This axis, normally x, this is going to be the theta axis. This is going to be the y-axis. So y is a function of theta. And you remember some of our points. And just to remind you, I'll go ahead and write them down here. Let's do 0. We'll skip a little bit. We'll do the 90, 180, 270, 360. And then for good measure, we're going to do 450. I want you to be thinking about, how do I get from here to here? All right, so the sine of 0 was 0. The sine of 90 was 1. 180 was 0. 270, -1. 360, back to 0. So 450 has what relationship with 90? If you remember some of the vocabulary, it is 360 degrees away, making it coterminal, meaning it's in the same position. So we can calculate the sine of 450 the same way we calculated the sine of 90. It is 1. And we'll take a few steps further. So 90 more degrees, we'd be at 540. 540 is coterminal with 180, meaning the sine is 0. And I think maybe you see what's happening here. So 630, right? 630 is coterminal with 270, -1. And then, of course, we're going to end up at 720, which is 2 complete circles, but it'd be at the same position as both 0 and 360. So it has a sine ratio of 0. Now, if we were to plot all these points, right, let's take a look at, let's make this 90 degrees, and this 180, 270, 360, and then we had, 450, 540, 630, and 720, right? So essentially what I'm representing here is 2 complete revolutions around the unit circle. And we'll just put this up. We'll make this 1. We'll make this -1. So watch what happens. At 0, we had 0. At 90, we're up at 1. At 180, back down to 0. 270, down to -1. And then 360, we're back up at 0. Okay, let's continue that, see if it's exactly the same the next time around. No pun intended. 450 is 1, 540, 0, 630, -1, and 720, 0. And if you can see that from my picture, let me see if I can make it a little clearer for you. You see, I happen to know these in-between values that occur. So essentially what this section means, that is the section from 0 to 360. That is one revolution around the circle, or what we're going to call one period, a word you might have used when talking about harmonic motion in physics. So if I continue on from 360, back up through the pattern here, that is another period. All right? So thinking about that, I've just graphed two periods of the function y equals sine theta. And essentially, if we just rotate around the circle forever, then this pattern results forever. So, how do we start to make some sense of this? This is a sine function, or what most people call a sine wave. One additional word you might see, a sinusoid, right? It has applications anywhere from heart rate to blood pressure to the tides and the moon, you name it. So, let's make some sense of this, all right? We'll also talk about cosine. So in our notes, all right, we have, let me see if I can lower this just a bit, get us down to ground level here. So we have some vocabulary. Period, the length of one complete cycle, right? This corresponds to around the circle one complete time, as in 360 degrees. The slang I like to use, one, if you can read that, one entire mountain, come on, you can do it. One entire valley. So what I mean by mountain, the part above. What I mean by valley, the part below. The amplitude, the distance from neutral to max or min. Essentially, it is the size of the wave, but it is measured from what we're going to call the midline. Of course, the midline is exactly what you think it is, a neutral position, a horizontal line that goes through the middle of the wave. Okay, so we call these the parent functions. They are essentially what we're basing things on and what we'll transform later on. But of course, the sine function, as we just went over, starts at neutral. That is key here because the sine of 0 is 0. Has a max of 1 and minimum of -1. If you look at the unit circle, you're going to get those same ideas from looking at the x and y coordinates at the quadrantal angles. Okay? It has a period length of 2 pi. All right, well, why did he say 2 pi? Why not 360 degrees? Well, they're equal. But what we want to consider is that if we're talking about, for example, if these are seconds,